Hi everyone, welcome to lesson 5, which is on acid nomenclature. Today what we're going to do is take a look at the special set of rules that are used when we talk about naming and writing formulas for compounds that we consider acids. All right, let's take a look at our first slide here. What I want to begin by doing is showing you or pointing out to you that when we talk about acids in chemistry, most of the time those acids are going to start off with an H in their chemical formula. While this is not true 100% of the time, it will be for the purposes of our class. So one of the easiest ways that we're going to be able to identify an acid is just by looking out for that H. Now, the other part about learning acid nomenclature is differentiating between the two types of acids. So as you can see behind me, we have binary acids and we have what are called polyatomic acids. Binary acids are hydrogen and one other element. So chlorine, bromine, fluorine, whatever that one other element is, it's just one other thing besides the hydrogen that all acids will have. We can also look at polyatomic acids. Polyatomic acids will also begin with hydrogen, but instead of only having one additional element, it'll have a polyatomic ion. So let's take a look at the rules for naming binary acids first. As you can see up here, it says that we are going to first identify the compound as an acid if it starts with H, which we've already done. And next, we're going to identify the acid as either binary or polyatomic. So really quick, this has hydrogen and one other element, chlorine. So this is going to be an example of a binary acid. Both of these involve polyatomics, so nitrate and nitrite. So I'm going to identify each of these as a polyatomic acid. Okay, for binary acids, we are going to use this kind of formula here. Hydro, and then blank, depending on what that element is, ic acid, where the blank is the root of the anion. So in the case of HCl, we're going to say that this is called hydro, and then because Cl is chlorine, we're going to call it hydrochlor. We use the root of that word, hydrochloric acid. So if we had HF, it would be hydrofluoric acid. If we had HBr, it would be hydrobromic acid. So you can just look at the root of that word and then kind of drop it into where this space is. For polyatomic acids, it's a little bit more complex. So one of the first things that you need to do for a polyatomic acid is identify the ending as either ate or ite based on the anion. So let's take a look at our two examples. If we have HNO3, ignoring the H for a minute, we have nitrate. Now, based on number 5, it says for anions ending in ate, which is what we have here, we're going to change the ending to ic acid. So nitrate will become nitric acid. For anions ending in ITE, we're going to change that to an OUS ending. So here we have nitrite. So this will become nitrous acid. It's very important that you identify the acid, if it's a polyatomic, by the ending, because we're going to need to know that in order to work backwards as well, which we'll see on the next slide. So when we're going from a name to a formula, it's a little bit easier, but it's also kind of tricky. So the first thing that you'll notice is that all acids will end with the word acid. So identifying an acid by its name is actually quite simple. The second one says we're going to identify the cation and the anion. Well, the cation is always going to be hydrogen, and the anion is either going to be an element off the periodic table or a polyatomic. So it says binary acids will begin with the prefix hydro. So we notice that this one has a prefix hydro. So that means that this is a binary acid. That means we have hydrogen, which is H+, and one other element. In this case, that one other element is going to be bromide. So that has a -1 charge. Then, when you're piecing this together, it becomes just like any other ionic compound that we saw earlier in this chapter. So we have a +1, we have a -1, they will cancel each other out. So our final answer here will just be HBr. When you have an anion with a charge that is different than -1, then you have to do a little bit of math, and that's what we're going to see in our second example. So, in our second example, we have a polyatomic acid. You know that it's a polyatomic acid because there is no prefix hydro in front like we see on binary acids. Same thing here. No prefix here, no prefix here. So both of these are going to be polyatomic acids. The next thing that you do is that you look at the ending and try and identify it as OUS or IC. If it ends as IC, we're going to go back to the 8 ending. So if you remember from the previous slide, we said that nitrate became nitric. So now we're working backwards. If we see the ic ending, we know that we started off with nitrate. In this case, we see the ic ending, so we know we started off with sulfate. So sulfate on your polyatomic ion sheet looks like this, SO4 2-. Combine that with hydrogen. In order to get a neutral compound, because we have a -2 charge here, we're going to need 2 copies of hydrogen. So our final formula is going to be H2SO4. We need 2 hydrogens in order to balance out the -2 charge on sulfate. Let's take a look at our third example. So our third example, we have the OUS ending. If it ends as OUS, that means it started off as ITE. So OUS is going to go back to ITE. So again, we're going to have hydrogen. This case, we're going to have sulfite. So instead of SO4 2-, we have SO3 2-. You can find that again on your common ion sheet. And once again, we're going to need 2 hydrogens in order to cancel out the 2- charge on sulfite. So our final answer for this problem will be H2SO3. Let's take a look at some additional examples. So before we get too far in this, I want to go through and identify these all as either binary acids or polyatomic. So looking at the first one, we have more than one element. So we have a polyatomic. Same thing with the next one. Next one's a polyatomic. Polyatomic. And then finally a binary, all the way at the bottom here. Okay, so going back up to the top, we're going to look for the name of this. So we go to our common ion sheet, we find PO4. We find out that the name is phosphate. So when we make this into an acid, we're going to call it phosphoric acid. 8 becomes ic. Let's take a look at our second example. In this case, we have CO3. CO3, if you look on your common ion sheet, is carbonate. Again, an ATE ending, just like we saw up here. So this is going to become carbonic acid. Okay, next one. We saw this actually as an example earlier. H2SO4. SO4 is sulfate, so it becomes sulfuric acid. And then finally, our last example like this, we have IO3, which is iodate. So it becomes iodic acid. Now, you have to be very careful. There are prefixes that look and sound similar to each other, but are just slightly different. So here is an example. If I had HI, this would be a binary acid, just like HF. And the name of this would be hydroiodic acid. Notice how similar iodic acid and hydroiodic acid sound to each other, even though one is HI and the other is HIO3. Okay, let's take a look at our last binary example. So a binary, remember, we're going to use that formula, hydro, and then something, ic, acid. And in this case, we have the element fluorine, so this is going to be hydrofluoric acid, hydrofluoric acid. One last thing that I want to make you aware of, here's another example. HIO. This is hypoiodous acid. Notice how close hypo and hydro appear. Please be careful. Take your time when you're doing this. Make sure if it's hydro, you identify it as a binary, but if it's hypo with a P, make sure that you identify that as a polyatomic. All right, let's look at numbers 13 through 16. In our first example, we have hydrobromic acid. So hydro, in this case, means we have H and one other element, and that one other element is going to be bromine. That has a -1 charge. Hydrogen has a +1 charge. Put these together, we get HBr. I have an asterisk next to hydrocyanic acid, and that is because cyanide is the one polyatomic that when we name it as an acid, it behaves almost like a binary acid. And as a result of that, it gets named like a binary acid. It is just an odd exception to the rule. So even though it's a polyatomic, it has more than one ion, we name it as if it's a binary using that prefix hydro. That's the only example like that. So you don't have to really worry too much about seeing that. The next one, we have hypochlorous acid. This is a polyatomic acid because it does not start with hydro like these two. In this case, hypochlorous acid means that we started off with hypochlor, us was ite, so it's hypochlorite, which is simply ClO -1. Combine that with our hydrogen +1, we get HClO. Finally, our last example. We have bromic acid. That means we started off with bromate. Bromate, you might recall from the common ion sheet, is BrO3 minus 1. Positive 1, negative 1, cancel each other out. You get HBrO3. All right, that wraps it up for acid nomenclature. Again, if you have any questions, please stop by office hours. Have a great week, everyone.